We were recently awarded an NSF ADBC grant, and ADBC stands for Advancing Digitization in Biodiversity Collections. And what we are doing is digitizing microfungi. You cannot see these with the unaided eye in most cases. You need some sort of dissecting microscope or a compound microscope in order to actually see the structures of these fungi. And they range from everything from common bread molds to powdery mildews that occur on your plants. A lot of them, unfortunately, are pathogens of plants and animals and other fungi. But microfungi also do a lot of good things as well. So they produce penicillin, which is obviously very important. And there's a huge range of other compounds that they produce. So the whole goal of this project is for us to capture images of the specimen label, and in a few cases, some of the actual specimens themselves, and put all of this data up online where it's easily accessible, not only to the public, but also to other scientists that can ask questions on big data.
My name is Elizabeth Lippold. I'm the project manager here, so I oversee all of the other institutions who are involved in this project to kind of make sure that they are on track with everything, because we have a lot of quotas we have to meet. We have a lot of specimens we're trying to digitize, and so we need to make sure that they get them in on time. And I also help troubleshoot with questions with workflow. In the beginning of the project, we want to standardize the workflow, so we've been bringing people in from the different institutions who are participating for the first year for training. So I've worked with people from like the Field Museum to University of Wyoming, as well as like Florida, and it's really neat to have them come in and sort of like troubleshoot the different workflows, as well as kind of get, because I'm not a mycologist, so it's really interesting to see the important issues from a mycologist's point of view and how important the project is to them. While I don't directly handle the specimens, it's really neat to work with our digitizer and see what sort of stuff he comes across.
I guess the simplest way to describe it is, we have a specimen, it's preserved, and there's information about where it was collected, when it was collected, who collected it, who identified it, and we want all of that information put on a record in this online database. So we're not imaging the specimens themselves. However, there are sometimes photographs that have been taken from a microscope, and one of the most important factors of this grant is making all of this information accessible and available to anyone who wants to use it. This is bringing together an insane amount of data. So for researchers to have access and easy access to this is going to allow for some really cool questions to be asked.
So what we can do is take these specimens, we can look at them and put them in the online database. And once we have that information captured, we can ask some really important questions. For example, how has human disturbance affected the geography of these fungi? So as we cut down a lot of our forests and dug up our prairies in Illinois, how has that changed the distribution of fungi over the last 150 years?
My name is Philip Anders. I am the biological informatician. These types of projects do provide information for a wide variety of people, of issues. I think it addresses things we've touched on: climate change, energy, economic issues. These types of projects provide data, and with multiple different other institutions together, we're creating innovative products that are going to forward the benefit for all of those institutions. Bringing that here at the Illinois Natural History Survey and the University of Illinois at Urbana-Champaign, I think that's bringing together a very dynamic group of people.